Hello, the subject of the lesson today is special relativity. I will talk about three phenomena that occurs when someone is traveling at very high speed, close to the speed of light. The first phenomenon is the increase in mass. The second phenomenon is length contraction. And the third phenomenon is time dilation. I will start with the increase in mass. Suppose the twin brother who goes on a journey in space weighs 100 kilograms on Earth. So m naught is the rest mass, and it is 100 kilogram. So when he will move in the spaceship at the speed of 80% of the speed of light, that is 240,000 kilometers per second, according to the mass increase equation of special relativity, his mass in the space will be about 167 kilograms, but he will not feel it. If his twin brother has mass detector, the detector will measure 167 kilograms. That means that its mass has increased by 67%. So the mass of the body of the human that travels in the spaceship in very high speed, the mass after the increase of the original mass is m, and m naught is the rest mass, or the mass of the object on Earth when it is not moving at all, and this we divide by the root of 1 minus v squared divided by c squared. So the mass m naught on Earth is 100 kilograms. Root of 1 minus 240,000 kilometers per second divided by the speed of light squared, and the final result is 167 kilograms. So the mass actually has increased by 67%. Okay, now I will talk about length contraction. As mentioned, the distance from Earth to the star epsilon has shrunk from 10 light years to 6 light years only, from the point of view of the twin brother flying in the spaceship. So because of contraction of distance, we see, yes, that the distance contracted from 10 light years to 6 light years, and actually I talked about it in the previous lecture, and I said that the total journey will be 12 light years, and in 80% in the speed of light will take him only 15 years. Okay, but in addition to the uh, contraction of the distance between Earth and the star epsilon, there is also another phenomenon of the 8 decrease or 8 contraction. The height of the man in the spaceship also shrinks when it travels in very high speed, close to the speed of light. Okay? And if on Earth is 1.8 meters, then from the point of view of the twin brother who remains on Earth, the 8 of the twin brother in the spaceship shrinks to 1.08 meters. So, as I have already explained, the length L is the length of the object or after the contraction, and L naught is the 8 of the twin on the Earth. Yes, the 8 is 1.8 meters, and if we multiply it by the root of the 1 minus v squared divided by c squared, it will give us the 8, the height after the contraction, that is 1.08 meters only. So if the brother on Earth had a detector or a height detector, then the detector would show a height of only 1.08 meters. But the twin who is in the spacecraft doesn't feel it. It doesn't feel that he is shorter. Okay, so we see that because of the phenomenon of length contraction, the height of the twin in the spaceship will be contracted to 1.08 meters from 1.8 meters. So it is contracted by 72 centimeters. Okay. Now I will talk about the third phenomenon that that occurs when someone is moving at very high speed, close to the speed of light, and the phenomenon is time dilation. As mentioned, from the point of view of the brother who is on Earth, his twin brother is moving in the spaceship at very high speed. Therefore, the rate of time flow in the spaceship will be slower than the rate of time flow on Earth. While on Earth, it took him 25 years for the twin brother to return from a journey in space. Yes, only 15 years passed in the spaceship because of time dilation. So we see that the time that is passed in the spaceship equals to the time that is passed on Earth times the root of 1 minus v squared divided by c squared. and the time that is passed on Earth is 25 years. We multiply it by the root of 1 minus 0.8 squared, and 0.8 is actually 240,000 kilometers per second divided by 300,000 kilometers per second, that is the speed of light. So the result is 0.8 and squared, and the final result is 15 years. So we see that the total time that it will take to the brother in the spaceship to do all the journey is only 15 years, because of the fact that the rate of time flow on the spaceship is slower than the rate of time flow on Earth. Okay. While from the point of view of the twin brother who embarked on a space journey towards the Epsilon star, he is at rest and the Epsilon star is moving towards him at a speed of 240,000 kilometers per second. Therefore, in this situation, there will be a contraction of distance according to special relativity, and the total distance between Earth and the star Epsilon will be 6 light years only, and the round trip distance is at 12 light years, and at a speed of 80% of the speed of light, the entire journey in a spacecraft will take 15 years only, due to contraction of the distance between the spaceship and the planet Epsilon and the star Epsilon as mentioned. So the total distance that the brother in the spaceship will have to do is the distance from Earth to the star Epsilon after it shrinks to 6 light years. So it does that distance back and forth. So the total distance it must to do is 12 light years, and it does it in the speed that is 80% of the speed of light. So the total way divided by the speed is the total time that will take the brother to do all the journey, and it is 15 years. As the same result is when we analyze it from the point of view of the brother that is on Earth, and he sees actually the time dilation, and from that reason, the total journey will take the brother on the spaceship only 15 years. This is from the point of view of the brother that is on Earth, but from the point of view of the brother on the spaceship, because of contraction of distance, the total journey will took him only 15 years, and as measured by the brother that is on Earth. Okay, thank you very much.